Energy is the ability to do work. This means making things move or change. It's everywhere. The warmth of the sun, the light from a lamp, and even your own movements are all powered by energy. Without energy, our world would be a very different place. No light, no sound, no motion. Think about it. You need energy to ride a bike, bake a cake, or even just think a thought. Energy is the hidden force behind everything we do. But where does all this energy come from, and how does it change from one form to another? Let's find out. Have you ever seen a roller coaster zoom down a track? Or a basketball soar through the air? That's energy in action. This is called kinetic energy, the energy of motion. The faster something moves, the more kinetic energy it has. A speeding car has more kinetic energy than a slow-moving bicycle. Even tiny objects like atoms have kinetic energy as they vibrate constantly. But energy isn't always about things moving. It can also be stored, like a secret weapon waiting to be unleashed. Imagine a book perched high on a shelf. It's not moving, but it has the potential to fall. That stored energy is called potential energy. The higher the book, the more potential energy it has. Energy can transform from kinetic to potential and back again. Think of that roller coaster. As it climbs the hill, it gains potential energy. Then, as it races down, that potential energy changes into kinetic energy. Energy is constantly shifting and changing, making our world a dynamic and exciting place. Energy wears many masks. We've met kinetic and potential, but there's a whole cast of energy characters to discover. Let's shine a light on a few more. Feel the warmth of the sun on your skin? That's thermal energy, the energy of heat. The hotter something is, the more thermal energy it has. We use thermal energy to cook our food, heat our homes, and power many industries. Ever wondered how a battery powers your toys? That's chemical energy stored in the bonds of molecules. When you switch on your device, the battery releases this energy, powering your fun. Then there's nuclear energy, the powerful energy locked within the nucleus of an atom. It's released during nuclear reactions, like those in the sun or in nuclear power plants. Light itself is a form of energy. Light energy travels in waves and allows us to see the world around us. And let's not forget sound energy, the energy produced by vibrations. Every time you hear a sound, you're experiencing sound energy in action. From the smallest atom to the vast expanse of the universe, energy exists in a multitude of forms, constantly transforming and interacting. It's this intricate dance of energy that makes our world so vibrant and alive. Section 4. Measuring energy we use. We use energy every day, but how do we measure this invisible force? Well, we use a special unit called the kilowatt hour, or kWh. Think of a kilowatt hour as a way to measure how much energy an appliance uses over time. For example, if you leave a 100-watt light bulb on for 10 hours, it uses 1 kilowatt hour of energy. We use kilowatt hours to track our energy consumption at home and in businesses. Your electricity bill shows how many kilowatt hours you've used, and you're charged accordingly. Understanding kilowatt hours helps us make informed decisions about our energy usage. By using energy-efficient appliances and adopting energy-saving habits, we can reduce our energy consumption and save money. Plus, it's good for the planet. Remember, energy conservation starts with awareness. By understanding how much energy we use, we can take steps to use it more wisely. Section 5. The Unbreakable Rule. Now here's a mind-blowing fact. Energy cannot be created or destroyed, it can only change forms. This fundamental principle is called the law of conservation of energy. Imagine a game of energy tag. Energy can run from one player to another, changing costumes along the way, but it never disappears. It's always there, just in different forms. Let's take a bouncing ball. When you drop it, its potential energy transforms into kinetic energy as it falls. Upon impact, some energy is converted into sound and heat, while the rest propels the ball back up, converting back to potential energy. This law applies to everything in the universe, from the smallest particles to the largest stars. Energy is constantly flowing, transforming, and interacting, but its total amount always remains the same. The law of conservation of energy is a fundamental principle that governs our universe. It's a reminder that energy is a precious resource that we need to use responsibly. Section 6. Energy in our world. Energy is the lifeblood of our modern world. We rely on it for transportation, communication, manufacturing, and countless other aspects of our lives. But our reliance on fossil fuels has led to climate change, a pressing global challenge. As we look to the future, it's crucial to transition to cleaner and more sustainable energy sources. Renewable energy sources like solar, wind, hydro, and geothermal offer promising solutions. These sources harness the power of nature to generate electricity without producing harmful emissions. By investing in renewable energy technologies, we can reduce our carbon footprint, mitigate climate change, and create a more sustainable future. It's a challenge that requires global cooperation, innovation, and a shared commitment to protecting our planet. Energy is a fascinating and fundamental force that shapes our world. By understanding its principles, we can harness its power responsibly and create a brighter future for generations to come. So keep exploring, keep questioning, and keep your passion for knowledge alive.